Okay. So I realized that I had myself muted on the stream, so let me just kind of redo that spiel. Um, so welcome all. Let's see. So this is what week 8. Only real announcements. We can anticipate exam 2 to be open up this Wednesday and be due this Sunday. I'll update the quizzes. I probably won't do a late penalty for the quizzes since I opened up many of them late. So, just kind of look at them. And the late penalty is not heavy, but I probably won't use it on the quizzes. Everything else should be fine. Yeah, otherwise, and so this week, we're going to be wrapping up chapter 3. So I did make a pre recorded lecture. I made it like maybe 4 p.m. On section 3.7. So what this interaction is going to serve as, it's going to serve as a Q&A, and I'm going to work through the homework for section 3.7, but we can talk about any homework assignment. It doesn't have to be from 3.7. And then the last section that we're going to do in chapter 3 is section 3.8, and we'll do that on Wednesday. That'll close out chapter 3. That'll get us ready for exam 2, and then next week we'll start the final chapter. It feels like an anime something. But chapter 4 will be it, and the final exams will be that first week of May. So we'll talk more about that as we get closer. Okay. So again, if you have questions, feel free to either unmute or type in the chat if you have any questions. And otherwise, we're just going to kind of hop into the assignments for right now. Okay. That should be fine. I'm not going to stress that. Let me see. Yeah, I'm not going to worry about it. It should be fine. Okay. So let's see. So let's start with the question. Okay, so this is a short section, and even the lecture was rather short too. Was fairly short. But I want to get to a question that comes from section 3.7. So I'm going to skip this for right now. If we have time at the end, we can come back to some of these others. So the topic for today is this idea called elasticity of demand. Honestly, I don't know that I've used it, but it's just an application of differentiation, and it made sense, and it seemed like it worked. It made sense when I went through it. And so elasticity of demand, what the idea is that, at least the impression that I got is that it's showing us the relation between price versus demand, right? Because in like business, as the price of a product goes up, the demand generally goes down. Like the more expensive something costs, the less people are going to want it. And then hang on, let me let the student in. Let's see, I gotta go like that. Come on, you are here. This is that student. Okay. All right, but yeah, so the elasticity of demand, it kind of gives us a sense of like how the model or how our system is behaving, and when we compare the price of our product versus the demand. In general, like as the price of a product goes up, the demand for it goes down. The more expensive something is, the less people are going to want to buy it, and the reverse is generally true. As the price goes down, the demand generally goes up. So what the elasticity, there's a theorem. As soon as they introduce the elasticity of demand, there's a theorem like on the next slide or whatever that says like once you calculate the elasticity of demand for a given x, if that x value, well, I don't want to misquote it. I want to say if it's less than 1, I think it says the total revenue is increasing. It might be the reverse, but I had to look that up. But it was real simple. But when you calculate the elasticity of demand, if it's less than 1, I think that means that the total revenue is increasing. And if it's greater than 1, the total revenue is decreasing. And then if you want to maximize the total revenue, see, now I don't know who this is. They need to, they should have their full name. I don't usually let students in. We hadn't had any trouble, but I generally don't let students in without like their name, because that's how I have a sense of who it is. I have a student in the waiting room. They just have an initial, so I'm inclined to not let them in. Let me see if I can do some deduction. See, I have too many students that could be. I don't know who that is. Let me send them a message real quick, and they should be able to do it. Let me go to view, message. Let me say change your name to show your student name to gain access. I'm not sure who J is. Okay. They should be able to see that. And they should be able to change it, so I'm not going to stress about it. Okay, let's see. Let me look at something real quick because I want to complete that thought on elasticity of demand. Yeah, so this is the elasticity of demand. It's basically like negative x times d prime, the derivative of the demand function over the original demand function. I want to pull up the theorem though. It should pop up. I just want to confirm something really quick. Okay, right here. Right here. So for a particular value, it's inelastic if it's less than 1. Let me see. The demand, okay, let's keep going. Is inelastic, so that means, yeah, I know when the elasticity of demand is equal to 1. Uh, I think the way it went was if it's inelastic, I don't want to guess it, and I'm trying not to look it up, but I guess I should just look it up and save myself. I'm gonna let it be for right this second, and we'll just kind of catch it in the flow. Okay, so let's work this one. Let me make sure my stuff is streaming properly. Ali Oxifree, that looks good. Okay, let's give this one a go. All right. So it says for this demand function, find the elasticity. The elasticity when P is this. State whether the demand is elastic, inelastic, or has unit elasticity. Here, let me click on the question help. I don't know if the book is going to open or not. If it does, that's exactly what I need. I just want to glance at the theorem number 11. It's not allowing me to do it. Come on, you can do it. Just go back. That's all I need you to do. Okay, wait, now it's opening. Yeah, that's fine. Stop. So the theorem, I just want to glance at theorem number 11. If we hop over. So again, this is the elasticity of demand. So how to calculate it is basically this formula. It's negative x times d prime over d. And then I'm looking for theorem number 11 right here. So the total revenue is increasing at those x values for which the elasticity is less than 1, right? I think that's what I said. And then when the elasticity is greater than 1, we say the total revenue is decreasing, and the revenue is maximized when the elasticity is equal to 1. That's all I needed. Okay, I think I can close this out. Oh, did I close the page that I needed? I'm sure I did. Oh, I knew that was going to happen. Okay, now I have to like go back and find, give me a moment. I knew that was going to happen. All right, let me just, I think we were working on question number 3. I got to set everything back up. Let's go to the next one. This is 3.7. Okay, so then I have to hop over here. That actually looks okay. I'm gonna do full screen and I need to share it with you all. Share. Let me let the student in for right now, but I'm gonna let them know, hey, I don't know who you are. I usually don't let students in or I don't know who they are. So hopefully it don't backfire. Share. So I just let a student in. Okay. I'm not sure if you were able to update your name or not. Just be sure to, you just want to have your student name shown to get credit. Okay. So there was a student that let in. His name was showing J, and I don't know who J is. I have too many J's. So just be sure. Did I get that student? Yeah. Go let him in. This is weird. Yeah, now it won't let, I don't know who this is, and it won't let him in. It's really strange. Like I keep hitting admit, and it's like it's not letting him in. Okay, it seems like it worked now. Okay, it looks okay. I guess he updated, so I'm not gonna stress about it. Okay, and I need to hop back over here. That's showing, and we're good to go. Okay, so let's give this a go. All right, so for this function, Okay, so let me take some notes here. Let's do like this, our paper, this, okay. This is question number 5. Oh, let me reboot this. This is doing that thing. It always takes a little while to kind of like dust off the cobwebs and get things like moving properly. But once we get going, it's okay. And it's like a sweet. It's like the timing is everything. Because if I load this stuff too early, then it like locks everything up. And what happens if you do it too late? Then we get behind. That's okay. But this is why I do pre-recorded lectures. So this is actually okay. So this is question number 5. This comes from section 3.7, question number 1. We have this demand function Q, which is in this case, is going to be D of P. This is going to be 327 minus P. And we're asked to find, so for part A, the elasticity. Okay, this is in business. Is in part B, find the elasticity. Let's do this. Let's copy and paste. The elasticity at P equals 89. And then I'm going to say elastic, inelastic, or unit elasticity. I'm going to say elastic, inelastic, or unit elasticity. Okay, I'll put question mark. And then part C, maximize the revenue. Basically, maximize the revenue. Okay. All right, so let's hop over to the tablet. Oh, is that working? Probably not. That looks healthy. Oh, and I can't hear it because of that. Okay, I'm gonna let it be. Okay, so these are the notes I just took. So the elasticity. So the elasticity formula, E of, I'm gonna write it in terms of X right now. E of X is negative X times D prime of X over D of X, where D is the demand function. Okay, so we're asked to find the elasticity of the given demand function. Okay, so then for part A, the elasticity of this P is going to be negative P times. So if we have, if the demand function is 327 minus P, the derivative of that is just going to be negative 1. So then D prime is just going to be negative 1. And then on bottom is the original demand function, 327 minus P. Okay. So this is our elasticity function. Okay. We can take it a step further. I mean, double negative will be positive. I'm just going to leave it. I'm going to go with this for right now. Well, we'll make some adjustments when we submit it on Pearson, but this will work for right now. Okay, with this. And let me copy this. Okay. So then part B, we're asked to find the elasticity when P is 89. That's interesting. Oh, I was like, why is it doing that? There you go. So then the elasticity when P is 89 is going to be negative 89 times negative 1 over 327 minus 89. We just have to use a calculator to crunch that number. Hey Siri, what's 89 divided by open parentheses 327 minus 89 close parentheses?
89 divided by 327 minus 89 is about 0.3739.
3739, right? Notice that that's less than 1. That is, I always forget. Yeah, that's the first one. It's less than 1, so that means that the price is, the total revenue is increasing. And I think that means that, I think that's an example of inelastic. I think it's inelastic. But yeah, it's less than 1. The main thing is to note that that's less than 1, and I think that means that the price of the revenue, the total revenue is increasing. Okay, let's let that be for right now. And then to maximize the revenue, the revenue is maximized when the elasticity is equal to 1. So then for part C, they're basically asking us to find, when E of P, we want to find what value of P makes the elasticity equal to 1. It's called like the unity elasticity. That's where the revenue is going to be maximized. Um, okay. So then for our case, that's basically going to be P over 327 minus P equal to 1, and we solve this. I'm a fan of setting it to 0. So like if we did, you're going to have 327 minus P on bottom. The P carries. If we said minus 1, that's going to be 327 minus P over 327 minus P. So then we're going to have minus 327 plus P, okay, equals 0. So what I did, I subtracted the 1 from both sides. I got a common denominator and then combined the numerators. And that's how I got to this point. So then, again, a fraction is only going to be 0 when the numerator is 0. So then all we really have to do is set the numerator to 0 and solve. We get 2p minus 327 equal to 0. Add and divide. P equals, let me see. That's a 1. 12 is 6. 7 is 3.5. So this value of P, when we plug it into the elasticity, is going to, it should be equal to 1. And so that's when the revenue is going to be maximized. Okay, so let's use this information to answer the questions that were being asked. So I'm going to hop back over to Pearson and plug in some results. So the equation for elasticity, if we go ahead and simplify that, the numerator ends up being just P. We're going to say P divided by 327 minus P. Okay. Find the elasticity 89. Type an integer or a fraction. Can we simplify that? Hey Siri, what's 327 minus 89? 238. What is that? Let's see, it's a 5 and an 8 is what, 13? 17. Simplify. Okay, let me put this in my calculator so I can get the simplified fraction just to make sure. I was trying not to use the calculator, but I just want to make sure that it's simplified so we don't waste more time. Let's go here. I'm just not showing the calculator. I'm just pulling it up on my end. I want to reload and refresh. Let me do that one more time. Okay, so if we do 89 divided by 327 minus 89, and I'm gonna hit math as a fraction. Okay, 89 over 2, did I type that right? Yeah, 238. So let's just do 89 over 238. I just wanted to make sure that fraction was simplified. Okay. So then that's fine. And then, so this is like the first case because the elasticity was less than 1. When the elasticity is less than 1, that means that the total revenue is increasing. And I think that's called it being inelastic. I think that's what it's called. Okay. Find the values of P for which the total revenue is maximized. Value or values of P. So we got 163.5 to the nearest cent. So 163 and $163.50. Let me see. Find the values which the revenue is maximized and 50 cents. Okay. I feel like there should be questions. Let's work another one. Let me see the time. Let's just work another one and keep it moving. For this function, basically a repeat, right? So are the things that I can copy and paste? I think I can copy and paste this whole thing. So let me copy and paste from the last one. copy, paste, and then let me make my adjustments. So this is question number 6. This is 3-7 number 5. Okay. Our demand function is 400 divided by x. And this is a d, this is a x. 400 divided by x. Elasticity. The elasticity when x is 6, okay? So we make that adjustment, x equal to 6. And then we want to maximize. Okay, so let's hop back over to our notes. And I think we're good to go. So this is basically these are the notes that I just took from that question. So again, let's do the same thing again. So again, elasticity is giving us a sense of, is basically comparing the price that we're selling a product versus the demand. You know how as the price increases, the demand goes down, and as the price decreases, demand goes up in general. Um, so with the elasticity, it tells us, okay, what's the sweet spot for the revenue? Like, what's the sweet spot that we need to set the price at so that we can maximize the revenue? Because if we sell it too low, then we're going to be shortchanging ourselves, and if we sell it too high, then we're still not going to maximize the revenue because people are going to fall off. So we're trying to figure out, okay, what's the sweet spot? What price should we sell our product so that we can maximize the revenue? That's what the elasticity function is telling us. Okay. Okay. So let's write down the elasticity formula. So then E of x, we said it's going to be negative x times d prime, the derivative of the demand function over the original demand function. That's the elasticity formula. Okay. So we're given our demand function, which is our d of x. In this case was what, 400 over x. So let's go ahead and find d prime, right? So I'm going to use low D high. I know I could write that as 400 times x to the minus 1. I'm just going to use the low D high technique. So the bottom times the derivative of the top, that's 0 minus the top times the derivative of the bottom is 1 over the bottom squared, right? If you should be comfortable with taking derivatives at this point. And so, you don't have to follow my logic on how I went from here to here, but you should be able to do that on your own, going from here to here to find that derivative. There's at least 2 different ways that you can do it right off the rip. I just chose one, okay? So we have the demand function, we have the derivative of the demand function. So let's go ahead and find our elasticity. So then our elasticity is going to be negative x times, we have this negative 400 over x squared all over 400 over x, right? So if we simplify, if we do like keep, change, flip, we'll get negative x. Let's go ahead and account for that. Double negative becomes positive. I got caught off guard. Give me a moment. Trying to talk and think and breathe, and I don't know, something just came up at the wrong time. Okay. I'm going to try to talk. Maybe not. I'm just going to write for a moment. So double negative, let's see. We can actually do this. So this cancels one of those. That cancels that. Is it 1? It looks like a 1. Am I missing something? It looks like it's 1. Let me see. Let me check it one more time. Negative x. Bottom. Yeah, I think this was like 1. That implies that has a strong implication. maximize the revenue. It sounds like it's maximized for all values of x in the domain. This is kind of weird. Let me check it one more time. Okay, so we got a unique result. I'm gonna hop back over to Pearson, and I'm gonna kind of check some things. So the elasticity function that I'm getting is 1. Yeah, that's interesting. Find the elasticity at the given point. So because the elasticity function is just 1, no matter what x we choose, the outcome is always 1. All right? Because there's no x to change it. Is the demand when x is 6? This is going to be unit elasticity. Because when x is 6, the output is 1. Sorry guys. Final check. Okay. Find the value. Give me a moment. I'll be right back. All right, I think we're good. We're gonna try. All right. Find the value or values of x for which the total revenue is a maximum. Again, the revenue is maximized when the elasticity is equal to 1, but the elasticity is equal to 1 for, it seems like, for all values of x. So let me see. The total revenue is independent of x. Yeah, I'm gonna go with B. Assume that x is in dollars. I'm gonna go with B here. Yeah. And I mean, it was just weird, right? I can't really give a concrete explanation. Like, there's not one value. It was like all the values of x. So that's why I said the revenue was independent of x in this case. Okay, that was strange. Let's try it again. We have another example. So let me move this over. All right, let's try it again. So this is question number 7. Can I just paste? Awesome sauce. Okay, let's undo. Let's undo back up a little bit more, and now let's paste. Because I think this is basically a repeat of the previous 2, just with different numbers. Okay. So this is question number 7. This comes from section 3.7, question 7. Our demand function is root 494 minus p. Square root of 494 minus p. We want to find the elasticity when p is 122. And I think everything else is the same. Okay, let's hop over to the tablet. Make sure that's showing. Okay. All right, so again, elasticity formula. Again, one of my mentors would say every time you use a formula, write it down. So that's why I try to go out of my way to rewrite these formulas each time. The elasticity formula, if it was in terms of x, would be negative x. Here, let's just go ahead and write it in terms of p, since we're using p instead of x. E of p is going to be negative p times d prime of p over d of p. Okay. Part A, why did I do that? So then the elasticity here is going to be negative P times. So now D is there. Let me go ahead and find D prime. Let me back up and go ahead and find D prime first. So then our Q, which is our demand function based on P, 494 minus P, like this. So then D prime of P, the 1/2 comes down, the 494 minus P stays, and then the exponent becomes a negative 1/2. Then we got to say times the derivative inside, that's going to basically be times a negative. I'm going to leave it like that for now. So I just took the derivative of that square root function. Okay. So then the elasticity function, I don't know what I'm writing, is going to be negative P times D prime. So you got this negative 1/2, 494 minus P to the power of a negative 1/2. Okay. That's going to be over the original function. Not there. We got the root of 494 minus P. Okay. Let me move this down to the same page. Or, yeah, another page. And then we can simplify this a lot. That negative square root, that negative 494, that goes to the bottom. So then you have something times itself. So the radical is essentially gone. Let me see, double negative is positive. So it looks like we finished with 2 times 494 minus P under P, right? And we can, let me see, we could go a little bit further, but I think that's enough. Then we're asked to find the elasticity when P is 122. 122, so basically you plug 122 into there. Hey Siri, what's 122 divided by open parentheses 2 times open parentheses 494 minus 122 close parentheses close parentheses?
122 divided by 2 times 494 minus 122 is about 0.1639.
1639. Okay. Notice that this is less than 1. So that means for a small increase in price, the total revenue increases, which means that this is inelastic. This is an example of inelastic. And then the revenue is going to be maximized when the elasticity is equal to 1. So for part C, we want to do this 2 times 494 minus P under P. We want to set that equal to 1 and solve to maximize the revenue. Let me see. So I'm going to do P minus this 2 times 494 minus P over 2 times 494 minus P. And this is going to be equal to 0. Again, the technique I'm using, I'm subtracting 1 from both sides, setting equal to 0. I get a common denominator, and then I subtract my numerators, and I get to this point. Okay? So then again, a fraction is only going to be 0 when the numerator is 0, so it suffices to say just basically set the numerator to 0. So we're going to say P minus 2 times 494 minus P. We're going to set that equal to 0 and solve. Let's see. Hey Siri, what's 2 times 494?
2 times 494 is 988.
And 988. Okay. Minus that, and then double negative plus 2P equals 0. So then we get 3P equals 988. So then P equals 3. So 2, 28, 27 will be what? 9.3 bar. Hey Siri, what's 988 divided by 3?
988 divided by 3 is about 329.3333.
Okay. So then if we sell our our product at this price, let me see. Okay, so let's use this information to answer the questions. I'm just trying to get back to the beginning. Okay, that's it there. Okay. So let's hop over to Pearson and answer the questions. So the elasticity function that we got, I'm going to do it like this. P divided by 494, 8, what do we say? 988? $988 minus 2p. Okay. And then 122 probably wants a fraction. Talk on it. Let me use my other calculator. I don't know why. I keep avoiding it. So we're going to have 122 divided by 2 times 494 minus 122. Double close parentheses. And I'm going to hit math as a fraction. 61 over 372. 61 over 372. Okay. 61 over 372. Okay. The 61 over 372 is less than 1, so that's an example of it being inelastic. Okay. Find the value or values for P which the revenue is maximized. The revenue is going to be maximized when the elasticity is equal to 1. And we got that occurs when P is equal to 329.3 bar, round to the nearest cent. So it's going to be 329.33. Okay, I feel like there should be questions. But maybe, I mean, it's this again, this is just an application of the derivative, right? So it's just a business application, you know, it's not too bad. It's kind of fun. I don't know if I feel like doing this though. I am kind of spacing out a little bit. We still got a solid like 30 minutes. And I probably wouldn't keep you for that long. I'll probably keep you. Let's try to do like maybe like 2 more, then I think we'll probably be at the end. For this demand function, can we get, well, this one's a little, it's not that, it's the same concept, it's just a more challenging derivative. Man, I'm being totally lazy. Let's power through. Let's just power through. Can I paste still? That would be nice. Okay, so I can still paste. So this comes from section 3.7, question number 9. So let me write that out. Our demand function is 700. Let me get rid of all of this stuff. I'm going to redo this as well. So we get P plus 1 squared on bottom under 700. Okay. And then we want to find the elasticity when P is 6. Okay, let's hop over to the tablet. And it's like that choking I experienced earlier, I didn't feel like I couldn't breathe. It was just annoying and like kind of embarrassing because, you know, I couldn't stop it. But I could breathe. And it's like, I didn't feel like I was about to die. So I was just like, will you stop? I'm trying to talk. And so I was like, okay, I knew I had to get up and go like drink something to just flush the system. Let's see. All right, so elasticity function or formula. I guess we can do it in terms of P. Negative P times D prime of P over D. Okay. All right, so we have this demand function, our Q, this is our demand function, P plus 1 squared. I can already sense that like this derivative might be a little irritating. But let's give it a go. So then let's focus on d prime, and we're giving ourselves some space. So we want to take the derivative here, right? We can do the bottom times the derivative of the top, that's going to be 0, minus the top. The derivative of the bottom is going to be 2 times p plus 1 to the power of 1 times 1. That's the top, right? Bottom times the top minus the top times the bottom over the bottom squared. So that's going to be p plus 1. Now it's going to be to the power of 4. But this p plus 1 cancels one of these 4 and turns it into a 3. Okay? So then the derivative, that wasn't as bad as I thought it was going to be. The derivative looks like it ends up being, it looks like a negative 1400 over p plus 1 cubed. Okay? So then if we want our elasticity function, it's going to be negative p times d prime, which is this guy, all over the original, which is 700 over p plus 1 squared. Okay? If we do keep change flip, let's write it out to simplify this. So then E of p, we get this negative p. I'm gonna go, I don't know why I always do it late and at that time when I do, but I'm gonna go ahead and account for the double negative. We're gonna have p 1400 over p plus 1 cubed times, keep change flip, p plus 1 squared over 700. Okay, that actually helps us out a lot. These two cancel 2 of those. This turns this into a 2. Okay, so then it looks like our elasticity function, looks like it's 2p, we got this p plus 1 under 2p. Okay, I think that's it. That's the elasticity function. Then part B wants us to find the elasticity when p is 6. Okay. That's basically going to be what, 12 over 7. Notice that this is larger than 1. So this means that's an example of something that's called elastic. And what that means is I want to say a small increase in the price is going to decrease our total revenue. Right? This is an example of something that is elastic. A small increase in the price should decrease the total revenue. Right? So then let's go ahead and find the sweet spot. Like what price should we sell our item to find that unit elasticity? So then we want to set the E of P, we want to set that equal to 1 and solve. So then we have this P plus 1 under 2P. If I set it to 0, we're going to have 2P minus P minus 1 over P plus 1 equals 0. It's the same reasoning as the previous two examples. 2P minus 1P is just P. So then we're going to have P minus 1 over P plus 1. Again, a fraction is equal to 0 when the numerator is 0. So then ultimately, it looks like P should be $1. So it sounds like to maximize the revenue, we should sell it for $1. And we can find the total revenue. It should be sold at $1 per day. And then if we want the demand, like how many can we expect to sell if we sell it for $1? The demand function was given. So if we plug a 1 into the demand function, if we sell our item for $1, then we can anticipate to sell 700 units, all right? Because if you plug 1 into that function, so the 700 units at $1, so that would be at $700 a day is the total revenue. And the argument is if we sell it for anything other than $1, we're going to make less than $700 in a day. So what we can check it by choose a price other than $1. Let's say we sold it for $2, right? That should be a case of it being elastic and the total revenue should be going down. let's see what happens if we let P be 2. So if we sold our item for $2 and we plug $2 into the demand function, what is that? 2 plus 1 is 3 squared is 9. So then 700 divided by 9. It's like 70. Maybe a little bit more than 70. Right? But that's still not 700. Is that right? I think I'm reading that right. That was a 2. Wait a minute. I think I made a mistake earlier. Yeah, let's back up. I think I made a mistake. So when P was 1, right? When P is 1, if we plug 1 into the demand function, 1 plus 1 is 2 squared is 4. 700 divided by 4, half would be what? 350? Whatever half of 350 is. 150, 175? I think it's 175. Hey Siri, what's 700 divided by 4?
700 divided by
Okay.
4 is 175.
So if we sell our item at $1 each, we can anticipate to sell 175 units in a day, and then so it seems like we can the total revenue earned on a day selling at $1 would be $175 per day. So now let's go back to our test. So let's say we let the price be 2 instead of selling it for $1. What happens if we sell it for $2? Right? So then what the demand would be if we sold it for $2, that's going to be 700 divided by 9. Hey Siri, what's 700 divided by 9?
700 divided by 9 is about 77.7777.
So about we can anticipate to sell either 77 or 78 units per day. Notice so we're selling less. So if we say 77.7, that's how many units we can anticipate to sell at $2. Hey Siri, what's that answer times 2?
Sorry, I didn't get that.
Hey Siri,
Question?
what's 77.7 times 2?
77.7 times 2 is 155.4.
Is that higher? No, because I think before we got 175, right? So notice we're making less money. If we increase the price beyond $1, we're making less. And I think if we sell it for less than $1, the money would still be less. The revenue is maximized at the value when we sell it for $1 in this case. Okay, so let's use this to go back and answer the questions, and I think we'll call it a day. We're close enough to the end. So so now the equation for elasticity, I got to get to hours to this question right here, right? Right there. 2p over p plus 1. So we got 2p over p plus 1. Okay. And then when we plugged in 6, it says type of integer or fraction. We got 12 over 7, which is, notice that that's larger than 1. 12 over 7. Okay. Is the demand elastic? So this is an example of the demand being elastic. And then the values for which the total revenue is maximized, that occurs when your elasticity is equal to 1. And for us, that occurred when P was equal to 1. So we sell it for $1. $1. Let me get $1. Hold on. Let me get $1. Dollar. Let me get $1. Anyway, so that was fun. Okay. Hopefully we did about 3 or 4 examples. It was all the same thing, just different scenarios. Same concept, just different numbers each time. Okay. So hopefully that was okay for everyone. Yeah, I can't really think of anything else. If there aren't any burning questions, we're actually going to end the session here. Okay, the chat looks clear. So, and from one beautiful mind to another, enjoy the rest of your day. Peace, guys.